Thank you for the invitation. I'm glad to be here. And I'm also glad to see so much interest in these topics. And as I heard, you're a lot of students also from landscape architecture, and I think we actually play an important role, and we will play a key role in future in the sustainable future planning and building it. So we had really interesting presentations before, and now I will scroll down and more in the detail. You know, we heard a lot about trees, and I will get more into the detail what these trees need and how we work in Graz to get the trees which we were talking earlier. So to presentate Graz, we had a detailed presentation of Vienna. And Graz is, you can divide Vienna from 7 to 10, and then you have around the dimension of Graz, something about this 300,000 inhabitants. We have around 270 hectares green spaces, around 26,000 urban trees, and we are 9 employees in the planning unit in this department of greens and waters. And our strategic fields, our topics for our work is at first, we heard it often today, the trees, for sure. Then we have the topic for the efficient use of water in this meaning of the sponge city principle, which I will present later. Then also the topic of the increasing biodiversity. For example, over here with these flowering meadows, we use it a lot in Graz, and it's also a really nice tool, I would say. Also the inhabitants like it a lot. And the last, perhaps a new topic for some guys of you, is the topic of the biochar as a long-lasting carbon sink. And this is also a goal for climate protection, not only climate mitigation. So, more in detail, our basic strategies, for sure, unsealing and greening where it's possible. We heard it in the morning also, we prefer the existing tree, you know, the big tree, which is there. It's the first. Always the first, not the new plantation. Only when this tree is nearly dead, then we make the new plantation. I will show you some examples. We use for the new plantation always climate-adapted tree species. I have some examples. Then these perennial, extensive mixtures and flowering meadows. We actually use no fertilizers, and only in the first 3 years we irrigate the trees, or on the long lasting for 5 years, but not longer. Then this implementation of the sponge city principle, and we also are in an intensive monitoring of our trees, and we evaluate them. We have 1,000 trees, 1,000 new plantations in this evaluation to check every year. How is it working, what we do, and if it's really function. So these things we heard before, I would say, you know, this urban heat island effect, but also when we now have the perspective from the view of a tree, you know, the tree needs the water in the underground, and what we are doing, what do we have in this dense sealed cities? We have a really increased runoff, but a decreased infiltration, and so it's not ideal for our trees. And today in this presentation, we are not talking about. The focus is on the dense areas. You know, when you have a park or something like this, you can put a tree in and it's okay. But now, when we are in the dense urban areas, we need these big canopies, as we heard it before, and often we only have 2 meters or less than this space for our trees. So big trees also require a voluminous root system. And what's in the underground? What do we have in the underground? We also heard it. Normally there are a lot of pipes, sewage system, electricity, gas, something like this. And also, when we don't have pipes in it, we have sealed soil, we have compaction, we have sometimes also infiltration of de-icing salts. And this is the unideal conditions. So when we look at this graphic from the colleagues from Germany, you know, we start with our plantation over here, and we want to come on the right, as rightest as we get. And normally with our tree pit, we are around here, or here, and there is a direct connection between the canopy volume and also the rootable area. So I want to give you some examples of what we can do that we can also get a lot more in this direction to become the tree older and bigger. And for example, only to have some numbers, in experiments with elder trees, there was a container with 12 cubic meters of tree substrate, and this was fully enrooted after 5 years. Only to have an idea of this. I think 12 cubic meters is there were a lot tree pits which I saw when I come here. They weren't such big, I think, not 12 cubic meters. So as you can see here, here's the tree substrate, and over there is normal, let's say, urban soil or urban substrate, and often it's also compacted. And so the tree not always enrooted because it's a lack of oxygen and also of water in it. So it can also be that the tree then find his other ways or he will die. So this is an example from our urban tree population in Graz. And as you can see here, I said earlier that something about the climate-adapted species. And as you see here, these are 26,000 trees. And over here, it's, I would say, 1/4 or a bit more. These are all not climate-adapted species. So we know that in the next 10 or 20 years, they will die because of the longer droughts. This is our analysis of the condition of our tree population. We see that 1/3 of the tree population in Graz is quite good, one is good, and there's 1/3 which is already moderate or bad. There are measures required, or they will die within some years. And over there you see this is the tree replacement per year. These are the trees which die and were planted new, around 300. And this is my work, the new plantation, 500 now. And when you have this in relative, you see we have to do work. When we need more ground, we want to have more trees. We also must compensate these trees which will die in future or in near future. And also the challenge is that when you see the tree pit, it's not only to make a new plantation. You have these site conditions. And when you're a landscape architect which is going out there at afternoon, I hope you're not planting a tree in this tree pit. It's not a technical standard now. Or the tree will not die. For example, this is the Styphnolobium. But you have this demolition in the infrastructure is also not really nice. And we heard it before, it's also this new EU restoration law that we want to expand the crown canopy area. And these are big challenges. So now in these really dense urban areas, we started in 2017 with this so-called Stockholm solution, because the colleagues from Sweden, from Stockholm, invented it. And it's the idea to, in this, where the area is really, you don't have a lot of area where the tree has a rootable volume. So we start to go underneath the pavement with a coarse gravel, with a big gravel, and we also have normally some pipes also in it. It's possible. And we are infiltrating the runoff through the gully in the underground. So it's important that this rootable substrate is always, there's always air in it, always enough water, and we have maximized the rootable value. But actually, I can tell you, it's also not enough when you want to have a 100-year-old tree which needs perhaps 150 square cubic meters. But it's better to make it this, because it's the first years, let's say the first 10 or 15 years, the development of the trees is quite better, and it's really better start in the vitality of the tree for further on. So I will show you some projects we made in Graz and also the progress of the trees. This was planned in 2030 from the planning architect Studio Boden, landscape architect in Graz. And there was the challenge that they said, we have to infiltrate all of the water from this area in the underground and not in the sewage system. So I said, okay, then let's try it out and let us infiltrate all this water in this rootable underground, and then we don't need the system, and don't make on the one hand the infiltration system for the sewage water for the runoff, and also the trees on the other hand, and this should be summarized. So it was the second pilot project, and we used this finer gravel. It's around 6 centimeters in diameter, and we mixed it with compost and biochar, as the colleagues from Sweden also do. And there you see the gullies, the inlet, where the rainwater gets in and is distributed underneath. So, and there's also where you plant the trees, some more normal tree substrate, so that the tree has the first 2 years more water around the new roots. And there you can see when it's finished. And we also have one tree planted in a normal tree pit with normal tree substrate, planted at the same time. And there you see the difference on the left and on the right in the progress of the trees. This is 2 years after. It's planted, it's a climate adapted, really nice tree, the honey locust. And there you can see these really dark green branches, and this is a photo from this year, so they're a quite big crown and a really nice development. Over there, it's actually 1 crown now, as you want to have it for a place after 4 years. And there you see the comparison between these two. It's okay, this progress of this tree, but better is it on there. You have the longer branches, and this is what we want. And actually, we also have the benefit that this water which came down is not more in the sewage system. Other example from the Leonhardstraße, it's a classical situation, you know, where the tram, there's a tram station, and there we planted the resistant elm. I saw it in Ljubljana also. You use it also. In the station, we made this structural soil underneath totally and infiltrated the water. And over there, we did it normal, only to try the first years. And I can show you. You can guess what's left and what's right. the same tree species planted at the same time in tree substrate, and this in the Stockholm solution. And it's bigger leaves, they are greener, and the branches are quite longer. And it goes on. You know, this is quite a good progress, but in this solution is better, and the open area from the tree is smaller than this one from the other. This is a photo from this year, a picture from this year. And you know, 4 years later, the tree gets until the second floor. It's quite nice. Also the shadow in the train station. Other example from the Girardigasse, it's a pagoda tree called pagoda tree, Styphnolobium. And there we tried in the tram station to make the tree pit bigger with a concrete system, but we didn't infiltrate water. And on the other side of the street, we planted a tree in the Stockholm system. And 3 years later, I put my fingers around, and it was incredible, the difference between the trunk, the two trunks. And you see it also on the crowns. This year, for example, these are in the train station. Also, they are not cheaper in the building because this concrete system is also quite expensive, and these ones over there are quite nice. After also 5 years. Or other example, we did this is an example where we put water in from a street with a lot of traffic. You know, there are a lot of heavy metal and all of these things which are actually not good. Also salt in this green line, and there we planted the alder. It's also a quite nice tree, and we put the gravel underneath the bicycle way. And this also have a really nice progress, as you can see there. So last one, good. So what we learned from all these examples now, what is our idea now? From my point of view, it's most important thing is to have enough air and water in the system, means also be porous onto the top. Means also not to use normal soil where the trees are standing. For example, here we put in some gravel only mixed with a bit of soil. It's called Schotterrasen in Austria, don't know the English word. So that all of the water which came from the pedestrian can infiltrate in this line, and the trees also can have this water and is separated from the outside. And when the people are getting from the car out and walk over the meadow, it's not such a compaction because the gravel can distribute the compaction better. Or also this example, as I shown before, these are also really, really coarse substrates. You know, there's only a gravel with 4% volume percent of a mature compost, and not more. And this is we see the seeds are around 80 species. And so we have on every spot, you have a different picture, because every spot is a bit, there are different conditions, and so you have a lot of different pictures with the same seeds, actually. This, for example, is where also the water comes from the street in and from the pedestrian area, and we have this tiny meadows which are also not so intensive work in the maintenance. This is one pilot project where I want to show you what is actually possible, because in this street we were able to infiltrate all the water because we built it in 2021. We are able to infiltrate all of the water from this street. Means that we infiltrate the water from the street through a planting pit with perennials. So you have kind of a filter, you know. Then we have the infiltration of the water through this permeable parking surface. And we infiltrate the water from the pedestrian area directly in the underground. And there's this structural soil is in one line on both sides. And we also put some of the roof water also in the system. And it's a scientific project where we make a lot of evaluation. You see over there this approach with the older trees. On the left one, we had this special. It's kind of a big truck which can suck a lot of air. All the soil around the tree and around the roots were put away, and we put the new substrate on it. Also this gravel substrate, and now we are evaluating how this horse chestnut, if it gets more in a vital than the other ones, because it's quite expensive also to do this. But this is the idea, to prefer the old trees which are here. But the horse chestnut has all the problem of the heat. It's not only the underground, but we'll try it. There you see it when we build it. There over the trees which were already there, and in between this parking lot. And over there you see the run of water which gets over there in and can infiltrate through this planting pit, and where you have this filter function. So one word now to biochar, because for me it's a really important and interesting topic, and I'm not sure if all of you know it actually. Biochar is really interesting material. You have a picture of it from quite new, 200 micrometer. It's kind of a sponge, a really, really fine sponge. And this sponge has an incredible large surface and extraordinary storage capacity for nutrients, water, and also air, and microbiology. And this biochar, instead of compost, is not degradable in the soil. It's interesting, because through this pyrolysis, through this burning procedure, you put this biomass, which is not persistent, in a persistent material. And so when we put it in the underground, we are sure that even when the conditions are worse, we won't get in an anaerobe milieu. So biochar is actually, when you burn the fire and when the flame is away, then you make it out. You won't let the coal burn down. But it's kind of it's not so easy, this process. But as you know, this normal coal. And it has a great potential, as I show you there. For example, when we built this tree pit with the Stockholm solution, we use around 20 cubic meters per tree. And we only put 8 volume percent of biochar in this substrate. So we have around of 3/4 tons of CO2 sink per unit, per tree. Long-lasting carbon sink in the underground. And it's also with the normal tree pit, with biochar substrate. We put a little bit more of biochar in it. We use a little bit less per tree, and there we have until 1 ton per tree carbon dioxide long-lasting carbon sink. And to give it a comparison, today I traveled from Graz to Ljubljana. I was with the train. It only took me 12 kilogram, or in the comparison of your consumption. For example, the average consumption of a Slovenian citizen is 7.4 tons a year. This means, for example, when we're planting 7 trees, then we can compensate the average consumption of one Slovenian guy per year. And we have it also as an advertisement for our Baumpatenschaften. You can buy a tree and you also have your carbon sink. This is the performance of healthy big trees. When we have this deciduous tree, 10 meter high, then this tree needs around half a liter of water to build 1 gram of biomass. He evaporates half a liter of water. It's a lot. For every 5 cubic meter of built substrate, as I presented it before, we have 1 cubic meter of water retention volume in the underground. Thinking about this flood and this heavy rains. Then there's also this transpiration performance. The evaporation of 100 liters of water results in a cooling capacity of 1 tree. This is the performance of 1 tree in one day in the summer. 100 liter, equivalent to 7 air conditioning units with 3,000 watts in operation for 8 hours. And also this carbon sink performance. We have around 40 kilograms carbon dioxide sink per cubic meter of substrate. Means when we use 20 cubic meters, around 1 ton for the tree location, and when the tree is 10 meters high, also 5 tons stored in the biomass of the tree itself. So the last statements to give you with. The first is to unseal as much area as possible, to use this really porous substrate from the bottom to the top. Then the infiltration of the surface runoff, infiltration of this runoff from the surface as much as possible to close the hydrological circle. Then to use the right trees, intense the construction site inspection, then the monitoring and evaluation, and also to participate the citizens in the communication when you are making such a project. Thank you for your attention.